All right, hey everybody. Today we're going to be doing some coding, and since it's introduction, we'll just be really focusing on just getting the basics. What is coding? How to set up code, stuff like that. So be sure to check me out on Friday's Rewind, and at the end we'll have an activity you can do to take a picture of to submit for participation credits. So to begin with, I wanted to share my screen and show you some codes I've written. Yeah, that's a good one. Let me see here. All right. Hopefully everyone can see that just now. This is a program I have called MATLAB. It's something I run for my schooling for Virginia Tech. I use this for my intro to engineering class. MATLAB is a coding tool, mainly with math. It's heavily used a lot for doing computational methods or any other math program. So you're actually able to do a lot of basic coding with this. And just to quickly show you a few things here, we have on the left is the command window. And then over here we have our workspace. So in our workspace, I'll highlight that right over here on the right. This is basically our script, our command script. We can write in anything, any program we want and create it. And then on the left here, when I run it, or it'll show us the output of what our script's doing. So in this case, I've created a code for a project that'll create an hourglass based on the size you want it. So if I enter the height of the desired hourglass, I put 5, I get an output of a 5 by 5 hourglass. But if I continue or rerun the program, say I want 20, it'll give me an hourglass by 20 on the output column. So this is obviously this program wouldn't do anything too, I guess, important. It's just kind of fun to do. But one of the great things about programs is there are a lot of applications for them. Try to get the right one. Okay, so this one was really cool that as far as coding goes, this is somewhat complicated. This is the introduction of almost a, in this case, a decision matrix based on mathematical values. So for this one, what I was able to do was I've created a code that runs in a cave, and a user would enter in methane concentrations within this mine shaft in parts per million. And if it reaches a certain amount, my program will output, hey, it's time to leave. So the way this will work is if we, let's say we put in something like 10. So we have our concentrations 10 parts per million, so the ventilation rate is 5. So everything's fine. But let's say we get something like really high. If we get something really high, it'll output danger, possible explosion risk, please leave area now. So coding, there's a lot you can do with it. This was just a few scripts that I've created for, like I said, class. And there's all kinds of fun applications with it. I made a GPA checker. You enter in the credit level of your class and what grade you're getting, and it outputs your GPA for the semester. And then in addition to that, you enter in your GPA for each year, and it'll show you your final or average GPA that you graduated with, how it calculates year by year. So there's all kinds of fun things you can do with code. I've even used this for personal use. I made a budget checker that you enter in um, money, uh, how much your goal you're saving to, and I created a math-based decision matrix that decides if you can purchase or not. So all kinds of fun stuff you can do with coding, and this is just one application of it. We'll be using mainly Scratch and Code Academy, code.org, but the Scratch is the big one we'll use. It's play and plug type coding. So it has all of the basic script like this, or I'm pointing, but you can't see. All the script on the right, it already has written in, and you will just plug and play to put in what you want to happen. So that's a general introduction to coding. And now we're going to talk about algorithms, because before you can do any coding, you need to understand what an algorithm is. And it can seem kind of confusing at first. You hear algorithms and all kinds of movies. They wrote this algorithm that did this and that. You'll hear about it in AI, artificial intelligence, or algorithm helps the intelligence to learn. It's a lot less complicated than it sounds. And I'm going to show you guys this video because they do a great job explaining. I'm supposed to already have it pulled up. I can't see. Here we go. Yeah. You guys hear that?
Yeah, we can hear and see.
Okay.
What's an algorithm? In computer science, an algorithm is a set of instructions for solving some problem, step by step. Typically, algorithms are executed by computers, but we humans have algorithms as well. For instance, how would you go about counting the number of people in a room? Well, if you're like me, you'd probably point at each person, one at a time, and count up from 0. 1, 2, 3, 4, and so forth. Well, that's an algorithm. In fact, let's try to express it a bit more formally in pseudocode, English-like syntax that resembles a programming language. Let n equal 0. For each person in room, set n equal to n plus 1. How to interpret this pseudocode? Well, line 1 declares, so to speak, a variable called n and initializes its value to 0. This just means that at the beginning of our algorithm, the thing with which we're counting has a value of 0. After all, before we start counting, we haven't counted anything yet. Calling this variable n is just a convention. I could have called it most anything. Now, line 2 demarks the start of a loop, a sequence of steps that will repeat some number of times. So in our example, the step we're taking is counting people in the room. Beneath line 2 is line 3, which describes exactly how we'll go about counting. The indentation implies that it's line 3 that will repeat. So what the pseudocode is saying is that after starting at 0, for each person in the room, we'll increase n by 1. Now, is this algorithm correct? Well, let's bang on it a bit. Does it work if there are 2 people in the room? Let's see. In line 1, we initialize n to 0. For each of these 2 people, we then increment n by 1. So on the first trip through the loop, we update n from 0 to 1. On the second trip through that same loop, we update n from 1 to 2. And so, by this algorithm's end, n is 2, which indeed matches the number of people in the room. So far, so good. How about a corner case, though? Suppose that there are 0 people in the room, besides me, who's doing the counting. In line 1, we again initialize n to 0. This time, though, line 3 doesn't execute at all, since there isn't a person in the room, and so n remains 0, which indeed matches the number of people in the room. Pretty simple, right? But counting people one at a time is pretty inefficient too, no? Surely we can do better. Why not count 2 people at a time? Instead of counting 1, 2, 3, 4, 5, 6, 7, 8, and so forth, why not count 2, 4, 6, 8, and so on? It even sounds faster, and it surely is. Let's express this optimization in pseudocode. Let n equal 0. For each pair of people in room, set n equal to n plus 2. Pretty simple change, right? Rather than count people 1 at a time, we instead count them 2 at a time. This algorithm's just twice as fast as the last. But is it correct? Let's see. Does it work if there are 2 people in the room? In line 1, we initialize n to 0. For that one pair of people, we then increment n by 2. And so by this algorithm's end, n is 2, which indeed matches the number of people in the room. Suppose next that there are 0 people in the room. In line 1, we initialize n to 0. As before, line 3 doesn't execute at all since there aren't any pairs of people in the room, and so n remains 0, which indeed matches the number of people in the room. But what if there are 3 people in the room? How does this algorithm fare? Let's see. In line 1, we initialize n to 0. For a pair of those people, we then increment n by 2, but then what? There isn't another full pair of people in the room, so line 2 no longer applies. And so by this algorithm's end, n is still 2, which isn't correct. Indeed, this algorithm is said to be buggy because it has a mistake. Let's redress with some new pseudocode. Let n equal 0. For each pair of people in room, set n equal to n plus 2. If one person remains unpaired, set n equal to n plus 1. To solve this particular problem, we've introduced in line 4 a condition, otherwise known as a branch, that only executes if there's one person we could not pair with another. And so now, whether there's 1 or 3 or any odd number of people in the room, this algorithm will now count them. Can we do even better? Well, we could count in 3s or 4s or even 5s and 10s, but beyond that it's going to get a little bit difficult to point. At the end of the day, whether executed by computers or humans, algorithms are just a set of instructions with which to solve problems. These were just 3. What problem would you solve with an algorithm?
There we go. So, as foreign as an algorithm can sound, and as crazy it sounds with you have AIs and AI algorithms, essentially it's just a set of steps to complete a task. And we usually create algorithms for GPS tracking, anything we want. It's just a set of steps. So as you saw, the reason I did that video was because it showed pseudocode. So it showed what an algorithm was and how to set it up in pseudocode. That's just something I know a lot of programmers use to set up their code before they even ever implement it, just to see if it works hypothetically, and then they'll implement their code and then see what the program gives them. What I did a lot in MATLAB is I wrote my pseudocode in the comment as a comment, and then replace the comment with the actual code and see if it would work. So I had it was almost like structured in steps. So my activity for you guys to understand what an algorithm is to write it. If you guys were here well, not in the classroom, but in the after school program with me now, I'd ask you some examples of algorithms you've heard of or done, or just some common things like instructions, how to turn on a TV, or instructions on like if you get something like furniture, how to set up furniture. But since no one's here, because you guys haven't come to MHC yet here, the instructions I have for you guys is, I'm going to share my screen one more time. This will be the last one. Is to write a set of instructions in just normal English language on how to complete a task. And this will be our algorithm. So if you see mine here, my algorithm was on how to sharpen a pencil. So that'll start with select the pencil in need of sharpening, insert the pencil in the sharpening device, follow the device's instruction to sharpen the pencil, remove the pencil, and then I have a branch or an ad minimum to the end of it, which is repeat steps 2 through 4 until there are no pencils in need of sharpening. So if I was to run this as a code, it has a start by selecting the pencil I need. It has the action, insert the pencil into the sharpening device, follow the device's instructions to sharpen the pencil. It has an end, remove the pencil, and then it has a repeat until my desired action is completely finished. Repeat the steps until there's no more pencils to be sharpened. So this would be a very complete code. It's got a start and end, repeats till it's done. Now that you guys know how a code should be created, how it should be set up, and what an algorithm does, my activity for you guys is to write your own code, your own algorithm to set up anything you want, instructions on whatever you wanted to do. So Ishmael could maybe do instructions on how to get ready for a Zumba practice. Kiana can do instructions on how to apply makeup, so on and so forth. Whatever you guys wanted to do instructions on, feel free to do it. You can write it in the chat or whatever, or however you guys wanted to do it, and then send it to us. And then my challenge to that is, once you've written the code in the English language, try using pseudocode. So for the pencil, I could have used any generic modifier I wanted. So P for pencil equals 0. And that'll, well, I can start with SP would be my sharpened pencil. I set that to 0. And say I'd have P for pencils that need sharpening, I'd set that to 10. As long as my SP is 0 and my P, my pencils, are greater than 0, I'd run it through this process of sharpening. That's just some way you can set up pseudocode. So that's actually all I had for you guys. I know it was kind of quick, but that's it for today. And if you had any questions, you can ask me on the next Zoom next time we're doing coding.